All right, thanks. So yeah, today I'm going to present some high-level details about MoveIt and about the problems about securing MoveIt ROS communication. So MoveIt at this point is definitely not secure. So let's see what can go wrong with MoveIt and how exactly we might be able to secure it a little bit more. So first, I will just highlight the main features and interfaces that MoveIt provides. This is not an extensive list, but the main ways how to interact with MoveIt. Then discuss a really short use case of how to take move group and what ROS message channels are the most critical ones in the move group node. And then some considerations about hardware access. So, well, in general, for those who might not know MoveIt, it is an open source framework for interacting with robots, doing motion planning, executing motions on a robot, interacting with sensors, and that in a really easy way so that you can run your robot on a remote node, for instance, using a move group, run it in your own C++ application using MoveIt CPP, or doing online command streaming using the MoveIt Servo interface. Those three interfaces down here are the main ways to interact with MoveIt, and those three are, I think, the most important ones when it comes to securing MoveIt ROS communication as well. So the move group interface is probably the oldest interface that everyone is aware of and has already played around with when playing with MoveIt. Here you see the ROS motion planning panel. You can drag around your robot and effector, and the robot will plan and execute the motion depending on the goal state. So behind the curtains, there's a move group node running, which is a single node maintaining the robot state, the scene, which includes the world, the geometry in the scene, and a bunch of capabilities. So the critical parts in the move group node are ROS control interaction. So in MoveIt 2, it's using ROS2 control, of course. So there are a bunch of message interfaces providing the join state or allowing to run trajectories or position commands. Then there is a bunch of sensor input topics. For instance, the point cloud to Octomap perception pipeline, which allows just feeding a collision map into the scene, which is then used for collision checking. And also, Move Group uses TF a lot. It allows changing the scene geometry using different services or message topics, and it allows updating the join state using the normal join state topic. It does a bit more, but those are, I think, the most important parts of the Move Group node. The Move Group capability, which I already mentioned here, the capabilities. A capability is a plugin that allows running actions or services that implement certain behavior for MoveIt. So the most common used one is the move group action, which just provides an action interface for planning motions for the robot and executing them using the ROS control interface. And then there is the move group interface, which is used for actually implementing the application or for accessing the move group node from remote nodes in general. So it is basically a client node of Move Group that implements all the actions and services that Move Group provides. And it implements the default capabilities that are also available, like the Move Group action, planning scene changes, everything that Move Group provides can be done in a really easy way using the Move Group interface. It is also possible to run multiple instances of those. So you can run an ROS instance with a Move Group interface, then have another application code running different calls on the Move Group node from remote, and this will all work really fine together, but it adds to the system complexity. Here you see a very simple draft of the architecture. of a whole MoveIt instance. So on the left side, you have the user interface side, which basically right now is the MoveGroup interface. There has been a MoveIt Python interface in ROS 1, but in MoveIt 2, we don't have it ported yet. And then there's the GUI ROS plugins that allow interacting with MoveIt as well. Here you have the MoveGroup node with a bunch of classes that are depending on ROS, providing all the service and action interfaces to interact with MoveIt. Most of those are capabilities. And then there is the MoveIt core, which wraps all the features that MoveIt has, like collision checking, planning, the planning scene, everything that is actually doing the hard stuff is implemented here and is accessing mostly to plugins. So those things don't really use ROS a lot. The only ROS interactions from MoveIt core or MoveIt ROS components to other nodes are the robot sensor or ROS control interactions. So you have, for instance, a joint trajectory action to controllers. Well, this is still ROS 1, so in ROS 2 it might be named a bit differently. Then, for instance, sensor input, point cloud topics, depth cloud images, anything that you want to run in your capabilities, you might use topics like this. And then MoveIt is using TF for updating the transform of the scene geometry as well. So those are the things that actually interact with the world, and those are the things that actually interact with any user code or any application code, possibly on remote machines as well. Any question for this slide, maybe, because I will get back to it later, but maybe at this point it might be a bit confusing, or should move on? All right. Then there is the second interface, the MoveIt CPP API. Here you see very simple motion, just an example of that it can do anything. The MoveIt CPP is basically like MoveGroup, just without the remote MoveGroup interface. So it is a C++ library that wraps all the core components. You can do anything with it. It just doesn't provide MoveGroup interface access, and it doesn't implement any capabilities. You can just add your application code to the same class that uses MoveIt CPP. But it still uses all the robots-facing interfaces, all the world-facing interfaces like TF, ROS control, planning scene, maintenance is possible, sensor input, and so on. And then third is MoveIt Servo, which is another library for running streaming motions, mostly Cartesian input. And this one is also heavily based on MoveIt core components. You can run it with ROS messages or in C++ only mode, so both are possible. And it also uses the same ROS channels as MoveIt CPP, so TF, ROS control, planning scene, maintenance, sensors. And yeah, so let's take a look at MoveGroup, because that includes all the ROS communication that we use in MoveIt. So we had the MoveGroup interface interactions. Then we have all the capability interactions, which are based on what kind of plugins you load in MoveGroup. Then we have ROS control interaction, which includes commands like joint trajectory, position commands, or the joint states topic, which is also accessible using ROS control. And then TF and any sensor input that you have in your application. So this is a lot, and there's a lot that can go wrong with these channels, especially if you want to run multiple instances of maybe a user interface, or if you want to access different devices using the robot interface. So some examples of things that can go wrong in the system is, for instance, the MoveGroup capability has a vulnerability like move group action can be called by a third-party node, and then robot will plan and execute a motion that has not been validated. So, well, right now, anyone can just execute any action, so there's no preventing that. The planning scene monitor is a really central core component of MoveIt, which maintains the world, it maintains the robot state, the transforms of the robot or any attached collision objects. So you're free to modify this internal representation as you please. So anything that changes this world will change how the robot will behave and plan and move in this world. So there's a lot that can go wrong by invalid access to this. And then, of course, ROS control, just faking the joint state message can do a lot of harm alone. Executing motions from a third-party MoveIt node or a separate node, these are things that should be possibly prevented in a secure system. And then, of course, there's hardware. All of the things above were mostly talking about the MoveIt communications, but when it comes to hardware, there's some more things to consider. So how do we know what hardware we are talking to? So if we are running ROS control, we have no way to tell if it's really the robot that we are talking to, or is it maybe some other simulation? Is it the right sensor instance that we are accessing right now using a message topic? So those things are not really considered yet in MoveIt at all. We need to be able to trust ROS control interactions. In reverse, ROS control might only be accessible from a certain MoveIt instance, could be. And then right now there's not a lot of ROS2 support and hardware support in ROS2 at all. So we are just right now starting to improve that situation and getting started with the first full stack ROS setups. So, for instance, we are working on a head robot, the stretch robot. This prototype includes a full moving base with a manipulator and sensor, and it's also not rewired to any. It doesn't have a wired connection necessarily. So it includes a lot of options to test any security features. Also, we are right now working on implementing the ROS2 driver for UR. So if we want to set up a demo for any SROS related examples on the UR driver, we should also be able to do that really soon. I think the first demos are already running. Specific to hardware, I think there are certain real-world factors that might also be worth considering, like examples like communication over Wi-Fi. What can go wrong in that situation? Multiple move group instances in a subnet, conflicting sensors or input devices, and I bet there are a lot more things that might be worth investigating. All right. This was a really short introduction about what I thought might be worth discussing about MoveIt. And I'm really happy to hear anything you want to ask or contribute to this discussion.
So I'll go ahead and get started. Because I got a bunch of questions here on my list. The biggest one I'm curious about, you had a really nice list of security items that you've gone through and thought about. Can I ask you, what's the interest, what's the motivation that drove those? Is there interest in the community and the folks that you work with and the customers in actually solving these, or is this more of an uphill battle?
Well, right now, most of these weren't really a consideration because there wasn't a lot of support for securing these channels. So I think if you want to have a robot in production and you're not completely sure about that your system is contained in a secure environment, then those are the things that I would like to secure. I think that was my motivation behind these items.
Yeah, is there any one that's like sticks out as a higher priority than any of the others, or any ones that you think are the biggest concern?
I think the highest priority should be hardware access, but the hardware access is not necessarily an item of like move it of the move repository or of move it to in general. So if hardware access is secure and ROS controls access is somehow secure, then anything that relates to executing things, so all the capabilities are definitely worth securing, and those are really the things where you can, where any node can pretty much do with the robot whatever it wants. So securing these channels or the nodes that run these, I think is the highest priority.
Ruffin, I think you had something?
Could you clarify maybe on what you meant by hardware? Or you mean like hardware at a station between devices, or
Yes. So
verifying firmware, or
let's say you have a subnet of mobile robots, maybe multiple of those, and those are publishing usually to private topics that are somehow unique to their own instance. But could be that you have multiple sensors publishing the same message type to the same topic, and then you don't really know what publisher you actually need to listen to. So
you're talking about when a swarm of robots have a collection of shared and private topic spaces, and you want to verify there's no crosstalk.
Yeah, you might to be able to give other nodes access to it, but you don't want to have crosstalk by default, I guess.
And maybe another question I had is, do you have any scenarios right now where like move it is used in the field in non-controlled settings, like maybe something a little more exotic than your factory floor or your warehouse?
Yeah, we have
that might be pertinent to like abuse or sabotage or something that maybe might be more intentional to attack. I don't know.
Yeah, I mean, most setups are of course secured by their subnets. Either they run in a VPN or only through direct connections that should be secure. But then again, we have scenarios where we want to allow remote access using, for instance, the move group interface in ROS. And if this connection was like, if the move group interface access was secured by default, then we would be a lot more flexible with maybe adding like changing access devices like laptops, or changing the location from where we access the robot. Things like that are easy to set up if we don't depend on the subnet per se.
It's more like a in-service
robot. Yeah, right.
Henning, are you familiar with SROS2 or DDS security, or what the capabilities are?
Yeah, well, in a very basic way. I just started reading into it.
Yeah, so I don't know if Mikhail or Ruffin, if you want to just give a quick overview of some of the stuff that's possible, some of the stuff that we had talked about kind of exploring with SROS2.
Sure. I don't know if you guys can hear me.
Yeah.
Okay, perfect. So SROS2 is like one of the projects that the security working group is working on, and so the main goal is to make it easier for users to leverage the security features provided by DDS. And so the main goal of that is to provide a set of tools that allow you to secure communication. So this is really focused on ROS communication and not necessarily tackling the other bits like hardware access or these kind of things. And so the goal is to provide you with enough granularity so that you can specify exactly what topics parts of your system are allowed to access or things like that, or what nodes are allowed to connect to your ROS network. And based on that, you can basically define rules on exactly this node is allowed to publish on this, call that service, whatever. And then this will be enforced by the DDS middleware, by the features provided by DDS security. And so that's what is provided today to various level of usability. And the things we've been like thinking of exploring that are on our to-do list is still allow you a bit more flexibility in both the ways how you secure specific topics. So in a sense of like maybe you may want some topics to be encrypted because anyone on your network that can sniff packets, you don't want them to get any like to be able to understand the information. But what seems to be more your case, sometimes you're more interested in being sure that the message both comes from the right person and hasn't been tampered with, more than protecting the privacy, the content of the data.
Yeah, I definitely agree to that.
And
Better performance anyway.
sorry, I didn't hear you, Kyle.
I was just saying that has better performance anyway.
True. And so then part of the tools we've been exploring is also like, as you can see on the simple diagrams you made, you already have quite a few like connections in your graph, and that was a very simplified one. And so writing by hand all these connections and all the things that are allowed to like talk to each other can be very cumbersome. So we've been exploring as well like tools to be able to basically generate that, like listen to your system in an unsecured way, to be able to give you a list of like, well, in that scenario of application, all these nodes spoke on all these topics, and these are the connections you need for your system to run properly. Then it's never ensured that it's going to be everything you might ever need in that system. So it's not a guarantee, in a sense that if you have a lot of fallback behaviors, a lot of new topics created in some scenarios or things like that, you may not catch that in this audit mode. But to give you like a good like starting point of all the things you need to have secured or declared, like allowed for your system to run.
Thanks.
I don't know if anyone wants to add or like some other aspects. That's a pretty like general things without getting too much in the weeds.
Yeah, I don't know, Kyle,
Yeah,
Jeremy, I don't know if you want to
I'll
mention Node.js. Oh, I'm sorry. Go ahead, Ruffin.
Yeah, basically we're just building off of making the features in Security DS more accessible. The access control plugin, encryption. It seems in your case that the integrity is sort of more paramount than necessarily confidentiality.
Yeah, I don't want to
and,
encrypt point cloud data. Definitely.
Right now we have a sort of a very conservative approach on like how our sort of default configuration is. One thing we might want to investigate is how we can be more optimized for various use cases, so that if you don't need encryption on all your particular topics.
Yeah, I think encryption is really not that important. Well, at least in the first place. And well, maybe there's some use in encrypting the user facing terms, which are mostly like action service requests, which typically don't include a lot of data. So might
How
be
much how much multicasting is conducted in Move It? Are like there are a lot of subscribers to like the single point cloud topic, or is it very linear pipeline?
Normally not. Like usually, if there's like something like the point cloud topic is usually only subscribed to by one subscriber.
Okay, most of the graph is just one-to-one.
Yes. Yeah. Well, from the user interface, there can be multiple instances. There you can have all of these accessed by ROS and also by a move group interface node, and maybe also by another node running the same channels pretty much. But all of these are not. I mean, they're definitely not performance critical. They're like single call services or actions that that don't really include a lot of data either. So when it comes to performance critical topics, most of them are really just one-to-one. And yeah, which would also include like the sensor data mostly. Point cloud data, laser scanner data, things like that.
So I'm thinking from a principal least privilege, or at least like a separation of concerns. How decoupled is the nodes and the code base that are core to MoveIt from the client or user-facing application code? Is there a strong segmentation, or do like consumers need to bind plugins into the running compose nodes?
Yeah, well, MoveIt ROS and MoveIt Core is not as decoupled as it should be. But the capabilities are pretty well decoupled, so you can run them dynamically if you really need to. So all of these interfaces down here, the actions and services, those are dynamic and really well decoupled. From the core components. That's it.
I guess that's a good segue to mention what Sid was saying. Like, Kyle, if you want to introduce, or if anyone from Canonical wants to talk a bit about NoDL and like how this could like interact with this idea of capabilities that are small bits of features that have their own like interface or needs.
Yeah, this is actually.
Ted, you're really quiet.
Oh, yeah, this is actually a pretty perfect example of where NoDL can come in. We don't have support for setting up permissioning yet, but automatically generating permissioning at least. That is something on the roadmap for the near future. But just including descriptors for what these default topic names are and what message types they're dealing with should allow like a nice automatic generation of keys, automatic generation of permissions documents, just based off of this very static graph of data flow you have.
So with permissions, are you talking about like permissions based on topics or interfaces? Like, for instance, move group interface could have all access, but then you could have like a read interface that only gives you get access to the getter capabilities.
Exactly.
All right.
When we're talking about permissions, we're talking about like read or write permissions to topics, call or host a service, or invoke or receive a action. So we kind of have this duality for all the various paradigms that IPC has over ROS.
Mm-hmm.
And then those are scoped to the namespaces of those topics, services, and actions. And we can be as narrow and fine-grained, even over the low-level DDS topics, those map to, or we can kind of be sort of high-level to like glob over an entire domain. So, if all your MoveIt topics were namespaced under like /MoveIt, and you want to be fairly lax, but just make sure that no one else could like read or write into that namespace, That's something you can do, or you could go to the other extreme and just lock down everything. But there's like, engineering trade-off with both of those.
Yeah. One thing that I would find really interesting with that would be like a monitoring permission, where you would have something like an ROS instance running remotely that is only allowed to read topics but not allowed to change anything in the move group states. So it would be like just made for monitoring or watching the robot state, but not for interacting with it.
Oh, so like something you might have like a diagnostic panel.
Yeah, something like that.
The factory floor, and so people can inspect it, but they can't necessarily modify it.
Yeah, that would be really interesting in that. In that use case. Okay.
So I guess one idea of like what is a NoDL thing. So what we're trying to abstract some of the notions of security in DDS to make it more accessible for ROS users. So that's related to what Rafin was saying. Like you could like write a document saying this node can can call that service, and then like SROS2 will take care of like understanding what that means in the DDS world. And the idea of NoDL is to be able to specify on a like per package and per node basis, like that you can describe, okay, this node is allowed to do this, and then when you integrate multiple nodes into your system, it could like read these individual files provided by like the maintainers of each components, and then be able to like generate a set of like all the connections like that need to happen, and like generates all the security material you need to make those work. And so that's pretty neatly connected to the idea of capability, in a sense that like a MoveIt like instance with like a ton of capabilities in it may expose a lot of interfaces, but some interfaces may be specific to some capabilities. And so for one setting where you just send, I don't know, like group trajectories, or like even simpler, only like position commands to ROS controls, then you don't necessarily need to expose all the velocity or acceleration or anything else that move group could expose, but in this case doesn't need to.
Yeah. All right. That definitely sounds really interesting.
There's one other capability that we've kind of kicked around a little bit, and that's with logging. Have you ever run across any needs for logging capabilities? Most of that comes from DDS, so it has to be ROSified back. But is that a thing that you've ever run across?
Yeah. Actually, sometimes we deal with like a lot of remote diagnostics. And I think in that way, logging is really important. Not necessarily from a security standpoint, but technically, if something runs in production, we definitely want to have that secured as well. And then encryption is also really important, right? But this is right now not really a MoveIt default feature, so we don't have any remote logging capability built into the MoveIt or MoveGroup node.
For debugging or diagnostics, do you use like ROSbag?
Yeah, it's mostly ROSbag. Of course the ROS console ROS2 logging, the default logging, but not any remote messages for that.
So one of the other things that we kicked around is we look at securing a full system like this. It's how to actually simulate it, and what work we can do without the real robot. It looks like this is pretty well decoupled, so that it's all the way on the right side of the interface. Everything else works whether you're running against a real robot or a simulated robot. Is that true?
Yeah, well, basically for MoveIt, it doesn't really matter if we run a real robot or a simulated robot. We only work with the ROS control interface. We have some sensor topics. Sensors could be ROS controllers as well. And behind that, we don't have any means to know what is actually running there. And with Move It, we also don't really know if we are running in a simulated world, for instance, or if we have simulated sensor data, or if it's a real device. This of course is an advantage, but it might be a disadvantage as well if it comes to security. But yeah, as I said on the last slide, I would say that Move It would depend on ROS control to be secure, and that might be a different use case after all.
In a deployment scenario, where you have, the OEM or vendor of the platform, and then you have your core stack, and then you have the user base code, do you think it would be advantageous to have constraints on who is delegated or responsible for billing permissions? So like maybe Move It and the vendor coordinate on what their minimal footprint is, and then Move It coordinates with the consumer on what their minimal footprint is. And so then you have this sort of very controlled setting where the consumer can't accidentally mess up with the hardware because sort of these stacks are interconnected and controlling for each other.
Yeah. So, well, we had a lot of internal discussions about running continuous integration on hardware from time to time. And I think for examples like this, it would be really important to give some users read access at least to certain data, or maybe write access to services that run the basic CI tasks, but no admin access for changing the robot state or world or anything really critical. So I think for examples like that, or for warehouse logistics setups also, it would be really important to be able to grant permissions or to have, well, at least secured node access.
I'm thinking like of a robot factory retailer. They buy the robot from the OEM, and they put their IP on top of it, and the OEM and the IP owner have like different certificates, because they're only responsible in securing what they have, and then you and the customer, the IP owner and the customer, interact on their certificates and how they want to exchange. And so
yeah, I mean, that sounds like it would require some like custom capabilities, but I think that would definitely be a use case. Like, for instance, if we have a certain camera device mounted on an arm, this also happens a lot, and those really need to register that you actually have the real camera device publishing to the right arm for any kind of visual servoing or so. Then I think it would be a use case to match those up.
So this has been really fascinating for me. I think for everybody else as well. Does anybody just in the security working group, do you have any more thoughts on kind of what our next steps might be? Anything else that we need to explore, or where we go from here? I mean, we'll take a look at another system or two, but any other thoughts on where we go from here?
I think we need to work to get it set up in SIM, and then go from there.
is there the demos you showed, those are like minimal viable examples running with the simulator in ROS 2? Is that that we
Yes,
saw?
yes, they are all available in the main repo and Move It too. So you can run all of these 3 demos with a Launchpad provided in there. I can post the link here if you need to.
And so I guess on our side, the minimal thing we would need to do to confirm that it can work would be to enable security for simulator, ROS control, and the Move It stack on top of it, and confirm that like if we have an RVs with admin access, we can use the Move Group interface. Is that correct, or is there something smaller, like even smaller, that we could do?
Yeah, I think I would focus on one thing at a time. It's definitely different use cases to secure the Move Grid interface or the robot interface. And I think the easiest way to get started would be to just focus on maybe just having the Arvis instance be secure to monitor Move Group topics. So I think this would also be the most interesting use case for the start, because most of the time your robot and the Move Group would be on the same machine, so you could have secured connections between on the same system. But Arvis might be running on a remote machine, and there you really need to make sure that you don't have access from any other machines that might interfere with the internal state. And when it comes to Arvis or the Move Group interface, those all use the Move Group action. The move action is really important. I think that would be one thing to start with. Not all capabilities need to be enabled from the start. They can all be disabled, but the Move Group action is really important. And for instance, the Get Planning Scene service. So I would just pick like 1 or 2 things and start with that and see how it works.
So I guess I didn't get a chance to look at your link yet, but do you think you have like one of these demos that expose only like a minimal set of capabilities? Like that would be like just a few actions that would be like the minimum viable thing to like ask for, like plan a path or like monitor a path?
Are the launch files like all monolithic? They just bring up everything you'd possibly need, or is that like navigation were like that? But maybe Mikhail might be looking for something smaller.
So the Move Group launch file in the path that I sent in the chat. This one starts the Arvis demo from above that I showed in the beginning. So you should be able to just play around with this motion planning panel, and there you will see everything running for Move It to plan and execute successfully. But it includes a lot of default capabilities that can be configured. But right now they all are enabled. So
it's a little more of a detailed question, but do you have any, are there any quirks in dealing with different RMWs? Is there any issues we should know about before diving in? Like it's only working with fast RTPS or Cyclone or something?
No, we were using the default until now, and we've tried both ways, and we didn't notice any difference.
Okay.
Yeah, for disabling capabilities, I would have to look up into like source code. I know It was done for ROS 1, but for ROS 2, we didn't have that use case yet. It's a bit different, probably.
One thing we've had with the navigation is there's just so many topics, the discovery takes a little bit longer. And also because of if you try to put all the permissions for the entire stack into one document, it ends up being slightly too large than the maximum permission size. So what's the scale, like about how many topics and services and actions would you gauge, like in the hundreds?
This
500?
Not necessarily. I mean, it really depends on what robot you're running. If you run this ARM, then it's really not that much. But if you run a full like humanoid robot with a lot of sensors, then you easily get into the hundreds. But for a really basic setup, it's I think maybe runs.
What's the system scale like? Does a one extra ARM duplicate all topics, or is it like 50% larger? Like what's being replicated in the topic space for ARMs, sensors, and joint spaces?
So of course, sensors scale by device. Sometimes there's a factor with like multiple topics per sensor. Like especially cameras have always multiple topics, different resolutions, different like camera info is added to their depth images. So those might be replicated. For hardware, well, it's not that much. You have the joint states, you have topics per controller interface, controller manager. Well, I can maybe launch something. I will launch the move group demo and see how many topics we have. That's maybe easier.
I was just thinking in terms of how dynamic the stack is, like whether I can imagine like the interfaces into the robots might be duplicated, like the controllers. I was wondering if like the control at the core planar, like there's a node for running the planar, if that's like duplicated for every ARM, or is it?
No,
context
those
switch
are all run in as plugins. So there's actually not a lot of topics running by default.
What's the count?
It's about 20 right now. It's really not much.
Oh.
Yeah, well, full list is 28 now. So 28 is the full demo right now.
I guess that's a difference from ROS 1 to ROS 2. I guess the action topics don't show up in the topic list, so you may have actually a lot more. I guess because MoveIt is using mostly services and actions, right?
3 actions are running by default right now.
Oh, okay.
Yeah, not all capabilities are enabled. Oh, but services 96. Oh, wow.
Let's multiply the 4 by DDS topic.
Yeah. All right.
How many nodes are there? ROS 2 node list or whatever.
Yeah. Fitting.
Okay, so I guess what could be the next step for us. So yeah, we'll try to run one of these demos. And like identify. So I guess the two things we would need to know to explore a bit further. So I guess the demos are testing, so we should easily be able to run them in like a Docker file or something. And then like the things we would like need, I guess, is that like an exact description of like what RVs should be allowed to do. So my understanding is that like it should be able to like listen to everything, but only call some specific services or actions.
Yeah.
And so I guess we would need to have an idea of like which ones these are.
One thing we haven't really taken advantage of in like policies, we've usually been affirming, allowing rules, but we haven't really done negating rules. So if that's the case, like a particular thing you want to allow just everything in this particular move its namespace and reject it, particular services that would affect the state, you could revoke permissions as well.
Okay. So how do you notice if something is permissioned or not? I mean, how do you handle that on the in the code? Is there a way to?
In terms of how that's configured, we have like a XML schema for writing permissions, but that's what the IDL is supposed to auto-generate for you.
Okay. So for instance, RVs could be configured to listen to the robot state, planning scene, changes, join state, anything. But it might be not allowed to run motion plans and execute them, right? So in that case, there needs to be a way to handle this gracefully, and the plugins are loaded dynamically. So when we start RVs and then launch a plugin, then there needs to be a way to know, well, you might be able to plan, but you might not be able to execute something or something like that. Is there a good interface to take care of these permissions?
That might be a use case of actually, you can use wildcards and permissions.
Okay. Yeah.
So in the case that like you're mentioning, where you have maybe a single console of the factory, and it's visualizing multiple robots, it'd probably be preferable if it alias over the robots, and you negate particular permissions regardless of what alias robot you're looking at.
Okay.
Okay.
Yeah.
That'd be useful, yeah.
Yeah, so we have the ability to whitelist or blacklist. We took mostly a whitelist approach so far, but you could do a blacklist approach for sure, and that's something we haven't leveraged too much. Then, as far as gracefully is concerned, it's not really like graceful so far, in a sense that like right now, basically what we do is like, okay, when you start your node, it will like instantiate some plugins in the middleware that will like load the rules and know for like what are the things allowed in the future. And so if in these rules you load that like, I don't know, like your RV's configuration has rules for the plugins you're planning on using, then when you start these plugins, even if you load them dynamically, it will work. But then if you try to create publishers that are not allowed in these rules that you loaded in the first place, then it will like fail to create the publisher. So RCL CPP or whatever would fail to create that publisher. And so then it's a matter of like how that exception is handled in Movit code. So right now I would guess it will not be graceful because it would be an uncaught exception. But
right. So
how often would it be if like RViz, like you load a plugin and RViz is like, hey, I can't really do this. Like it gracefully fails back from our CPP and just like, I'm not allowed to do this. And it like opens up a file dialog and says, point me to the certificate that would allow me to do that. Kind of neat.
Yeah, that would be nice. I mean, it needs to be implemented in the plugin then, but handling the exception is the least that should happen. Well, maybe one other interesting issue with Movit is that we are using like a separate private node in one class that is taking care of certain services. It shows up as a separate node. It adds a bit of like redundancy in the node list. Like basically there's some nodes are shown twice because of that. This is, I think, a ROS 2 issue, and we are looking into fixes for that, but it might be something that will confuse you when you start the demo.
Are you guys using compose nodes at all yet?
We
Like
are also using, we are using that with Move It Servo. So if there's something specific to compose nodes, then Move It Servo would be a nice example for that.
what is Move It Servo?
Well, Move It Servo is this streaming interface here. So it allows you to just publish or provide target poses, and the robot will just react to it online.
Oh, gotcha.
I'm not sure, did I post this one? No, I didn't. I just posted the first two interfaces.
So I guess we could look at that separately, but Move It Servo is interesting as well. So what it's doing is that like it's using the Move It framework to analyze the planning scene and see if the motions that are streamed are doable or not. But it's not necessarily doing specific, like it's doing just IK, and if there is no obstacle, it moves.
Yeah. So you can publish joint states or joint and effective velocities. Both will be accepted. So and then it runs in an inverse Jacobian internally, smoothes it, does some collision checking on it, and then forwards the result to ROS control. So you can have like those two ROS communication channels, the input and the ROS control communication. And then it also uses Move It core components like the planning scene monitor, which is pretty much like a ROS interface for maintaining the world, the collision world of the robot, and the transforms of the scene. So those are also accessible. But I'm not sure. I mean, that class is really complicated, so I wouldn't start with that one.
So I think this has been really helpful. I think we got kind of a way forward, some ideas. I'm sure we'll talk about it more when we next get together. Henning, are you able to forward the slides by any chance?
Yeah, sure. I can do that.
Yeah, if you could do that, then I'll upload those with the link to the video when that's published. Does anybody else have any final questions before we go? All right, and just a reminder,
We lost you, Sid. You muted.
Sorry. So next meeting, Marco, you're on tap for that, right? I'm not hearing you. I think you unmuted, but I can't hear you. But yeah, so that's on the 26th again. Then it's be 3 hours earlier than normal, and I'll be sure to Henning, if we got any more questions, we'll reach out to you. And you can ignore us if you're busy or whatnot. But yeah, thanks so much for presenting. And if nobody else has anything else, then we'll see you in 2 weeks.
Thanks for sharing this. Awesome.
Yeah, thanks for the super nice presentation. Very interesting.
Yeah, thanks for having me.
All right.
See you guys.
See ya.
See ya. Thank you. Bye-bye.